Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the Corbettmaths practice questions on enlargements and focus on the enlargement questions that use the array method. So rather than having enlargements on a grid, these are going to be enlargements where we're going to be using the array method. If you need any extra help on doing enlargement questions using the array method, if you go to Corbettmaths and go to video number 109, there's a dedicated video tutorial there on completing enlargements using the array method. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at question number one. So question number one, we've got this point P and we've got this right angle triangle A. And if we read the question, it says, enlarge triangle A by scale factor 3 using P as the center of enlargement. So we want to enlarge the triangle by scale factor 3 using the point P as the center of enlargement. So scale factor 3. So we want to enlarge this triangle A with scale factor 3 with this point P as the center of enlargement. So what we're going to do is let's do one point at a time. So let's start off with the top of the triangle. So this point here. So if we get our ruler, we measure the distance from the top of the triangle to the point P. That's equal to 3.4 centimeters. That's 3.4 centimeters. And we're going to multiply that by 3 because scale factor is 3. So 3 times 4 is equal to 12. Put a 2 down and carry a 1. And 3 times 3 is 9 plus 1 is 10. So that means this distance is 3.4 centimeters. But when we enlarge this by scale factor 3, rather than being 3.4 centimeters away from the point P, it's going to be 3 times further away. So that'll be 10.2 centimeters in that direction. So let's get a ruler and pencil. And as you can see, I've lined up the ruler. So the 0 is on the center of enlargement. 3.4 centimeters is on that top of the triangle. And 10.2 would be down there. So if we draw a line, a 10.2 centimeter line in that direction, we'll find out where this point will move to. So let's do that. And that's there. So this point will move to there. It's 3 times as far away from the center of enlargement in the same direction. Okay, now let's repeat this for the other 2 points. So let's do this point down here. Okay, so as you can see now, I've lined up the ruler. So the 0 is on the center of enlargement P. And the right-hand corner, the bottom right-hand corner of the triangle there is at 2.5 centimeters. So at the minute, it's 2.5 centimeters away from the center of enlargement. So whenever we enlarge by scale factor 3, it's going to be 3 times further away. So 2.5 multiplied by 3. Let's see what that's equal to. 3 times 5 is equal to 15. So put a 5 down and carry a 1. And 3 times 2 is 6 plus 1 is 7. So that'll be 7.5 centimeters. So we want to go back to the center of enlargement and draw a 7.5 centimeter line in the same direction. So let's do that. And that would be there. So this point would move to here, this point would move to there. Now let's do our last point, this point here. And as you can see, that's 4.2 centimeters. So we're going to take the 4.2 and we're going to multiply that by 3 because the scale factor of enlargement is 3. 3 times 2 is 6, and then 3 times 4 is equal to 12. So that'll be 12.6 centimeters. So we want to draw a 12.6 centimeter line from the center of enlargement through that other point. So let's do that. And that would be there. So we've now got our 3 points. Let's join them up. And that's it. This would be the enlarged triangle. So we've enlarged triangle A by scale factor 3 using P as the center of enlargement. And that's it. So this would be the triangle there. Okay, let's look at our next question, question number 2. Okay, so question number 2, we've got the point P here, and we've got this rectangle. And the question is to enlarge the rectangle by scale factor 2 using P as the center of enlargement. So we want to double all the distances. So let's start here and let's do this first point here. So that distance is 2.4 centimeters. So if we take the 2.4, and we multiply that by 2, double it, that'd be equal to 4.8. So we want to go 4.8 centimeters along in that direction. So let's do that. Okay, so this point would move to here. Now let's have a look at this point here. That distance is 3 centimeters. So when we double that, that'll be 6 centimeters. So let's double that and go to 6 centimeters, which would be there. So this point would move to there. Now let's do the bottom left-hand point. That's also equal to 2.4 centimeters. So let's double that, it'll be 4.8. So let's go 4.8 centimeters in this direction. So that would be there. And then finally this point here, that's also 3 centimeters. So when we double that, that's 6 centimeters. So let's double it and let's go to 6 centimeters. So let's go back to 0, the center of enlargement, and go to 6. And that would be there. And as you can see, I went a little bit too far and I've rubbed that bit out, so it would actually be just there. Okay, so now we've got our 4 points. Let's join them up. And that's it. So if we enlarge this rectangle by scale factor 2, it will then move to there. And that's it. Let's look at our next question, question number 3. Okay, so let's have a look at our next question, question number 3. So question number 3, we've been given this L shape, or backwards L shape, and we've been asked to enlarge it by scale factor 2 using the point P as the centre of enlargement. So it means that all these points are going to become twice as far away from the centre of enlargement P. So let's get our ruler and pencil, and let's start off with one of the points. I'm going to choose this top left point here. So this point here on the top left. So as you can see, it's 2.2 centimetres, so we're going to double that to be 4.4 centimetres. So we'll go back to the centre of enlargement and we'll draw a line to 4.4 centimetres, so 4.4 centimetres. So that's there. Okay, now so that's the top left point done. Now let's do the top right point, this point here. So let's measure the distance to the centre of enlargement. So that's 3.5 centimetres. So when we double that, that'll be 7 centimetres. So if we go back to the centre of enlargement and go to 7 centimetres. So we've got this point and this point. So that's going to be the top of the L shape. Now let's do this bottom right point here, this point here, the bottom right hand corner. So that's 4.6 centimetres. So when we double 4.6, 4.6 plus 4.6 is 9.2. So we'll go to 9.2 centimetres. So we've gone to 9.2 centimetres, so that'll be there. So we've done this point, and this point. And it's very important that whenever you're doing this, you're being as accurate as you can be. So here, whenever I done 4.6 doubled to be 9.2, I went to exactly 9.2, or as close to 9.2 as I could go. So now let's do this bottom point here. So that's 3 centimetres, so we'll double that to be 6 centimetres. So we've done this point, this point, this point, and this point. And now we've just got these two left to do, this one and this one. So let's do this point here. It's 1.7 centimetres. So when we double 1.7, we get 3.4 centimetres. So let's do 3.4 centimetres in that direction. So that'll be there. And then finally, this point here. So that's 2.8 centimetres. So let's double that to be 5.6 centimetres. And that's it, we've now got our 6 points. This point has moved to here, this point has moved to here, this point's moved to there, that point's moved to there, that point's moved to there, and that point's moved to there. So now let's join them up. And that's it, we have enlarged that L shape by scale factor 2 using P as the centre of enlargement. Okay, let's look at our next question, question number 4. Okay, so question number 4, we've got this triangle, and the question says, it says enlarge the triangle by scale factor half using the point P as the centre of enlargement. So we want to enlarge by a scale factor of a half, so that means that all these distances will be halved. The distance from here to here will be halved, the distance from here to here will be halved, and so on. So let's do that. So the distance from P to this bottom left hand point here is 9.2 centimetres, and half of 9.2 is 4.6. So instead of going to 9.2, we're going to go to 4.6, which would be here, 4.6, that's there. Okay, then this bottom right hand point here, I've got that's equal to 9.2 again, and half of 9.2 is 4.6, so that distance is 9.2 centimetres, so half of it would be 4.6, which is here. And then finally, the point at the top of the triangle. So the distance from the centre of enlargement to the top of the triangle is 17.6 centimetres, and when we halve that, it's 8.8 centimetres. So there's 8, 8.5, 8.6, 8.7, 8.8 would be there. So we've now got our 3 points, now let's join them up. And that's it, we've enlarged that triangle, the big triangle, by scale factor half, and that's it there. Okay, so let's have a look at question number 5. So question number 5 is a bit different than questions 1 to 4 because this time we've been given a triangle, the point P. You can see there's not much room here to the left-hand side because the question says enlarge the triangle by scale factor -2 using P as the centre of enlargement. So this time we've got a negative scale factor of enlargement. So that means rather than going in the same direction the triangle is, we're going to go twice as far away, but in the opposite direction. So let's do that. So the top of the triangle, it's 3 centimetres away from P. So we're going to carry on, but we're going to go twice as far away. So that was 3, double is 6, so we're going to go 6 centimetres in the other direction. Now we're starting here at 3, so we're going to go to 9. So we're going to go to 9, because here that means that this line is 3 centimetres, that bit's 6 centimetres. So that's where that point's going to move to. This point's going to move to there. Now let's do this point here, the bottom left-hand corner of the triangle. So the distance from the centre of enlargement to the bottom left-hand corner of the triangle is 3.4 centimetres. So that's 3.4 centimetres. So we're going to double that. So it's going to be 6.8 centimetres. So we're going to go 6.8 centimetres in that direction there. I did try this question earlier by moving the ruler along, but as I've done that, the ruler actually changed direction slightly. So what am I going to do is, I know from here to here is 3.4 centimeters. Doubling it is 6.8, so I want to go number 6.8. So I'm just going to do 3.4 plus 6.8, and that's equal to 4 plus 8 is equal to 12. Put a 2 down, carry a 1, and 3 plus 6 is 9 plus 1 is 10. So I want to go to 10.2 centimeters, so I'm going to carry on to 10.2 centimeters. So I've carried on the 10.2 centimeters, and that's there. So that means that this distance is 3.4, and I've gone 6.8 in that direction. You could, if you wanted to, just move along and measure your 6.8 like so, but it's just very important you keep it in the same direction. Okay, so we've done this point, and we've done this point, now just this point here. So let's measure that distance. So the distance from this point to the center of enlargement is 1.8. So that distance there is 1.8 centimeters. Doubling it will be 3.6. So we want to go another 3.6. But it's very important that we keep the ruler going in the same direction. Or what I could do is, I know that distance is 1.8. If I do 1.8 plus 3.6, that'll tell me where to go to. 8 plus 6 is equal to 14. Put a 4 down and carry a 1. And 1 plus 3 plus 1 is equal to 5. So I want to go to 5.4 centimeters. So 5.4 would be there. So this distance would be 1.8 centimeters, and this distance would be 3.6 centimeters. And that's it. So we now know that this point moves to here, this point moves to here, and this point moves to here. Now we just need to join them up. And that's it. So we have enlarged this triangle by a scale factor -2 using P as the center of enlargement. And as you can see, it's become twice as big, but it's in the opposite direction, and it's been flipped over. And that's whenever you enlarge something by its negative scale factor, it'll flip over like that. And that's it. So that's question number 5. And let's have a look at our last question, question number 6. So question number 6, we're told that triangle B is an enlargement of triangle A. And the question this time just says, find the center of enlargement. So we just need to find the center of enlargement. And the approach that we use for this question, without a grid, will actually be the same approach that I would use on a grid. So I would actually just join up the corresponding points and carry on in the direction as to where the center of enlargement would be. And I would do that for each pair of corresponding points. So let's do that. So I'm going to draw a line passing through the top of the triangles, like so. And then now I'm going to do the bottom right hand corner of the triangles. And I'm going to do the bottom left hand corner of the triangles. And that's fantastic. And as you can see, all of those lines pass through the same point here. So that is the center of enlargement. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on enlargements and enlarging shapes using the ray method. And that's it.